In this video, we will talk about the ArrayList, which is a list data structure. A list data structure is basically an ordered collection of values. And if you see the UML diagram, this is the ArrayList here, and this ArrayList class implements the list interface and it directly implements the collection interface. Apart from this, there is one more important interface, which is random access. We will talk about random access later, but for now, we can see that ArrayList is basically, it belongs to the list data structure, the list hierarchy. All right. So how do we initialize the list? How do we add elements? Let's see a quick demo of the ArrayList. To initialize the ArrayList, we use the class ArrayList. Then we provide the data type. So let's say we are going to add string values to the ArrayList. So we provide the type string. Then we name it L1 and new ArrayList. We can provide a size to the ArrayList, but we can also, for now, let's use the default constructor. That means if we don't provide a size, a default size will be provided by the compiler because that is written in the ArrayList class itself. Now we have a new ArrayList which is blank at the moment. So let's add some elements to this list. To add the element, we use the method add. Let's add a couple of elements here. Item 1, item 2, item 3, item 4. So we added 4 elements to this array list. Now once added, how do we get the element back? To get the element back, we use the get method. ArrayList supports a get method which accepts an integer value, which is basically an index of the element. So if you see, ArrayList has the same idea of indexes, same as arrays, zero based indexes. So this is index 0, this is index 1, this is at index 2, and this is at index 3. So if we want to print, let's say, item 2, then we will pass the index 1. Let's run this method. And we see item 2. Okay. Similarly, what we can do, let's print all the values. We start from 0, 1, 2, and 3. So we see all the values on the console. We added bunch of values and then we retrieve those values. To do that, we use add method and get method. Okay. Now you can see if a list contains maybe 10 elements or 50 elements, it's not always an efficient way to get the values in this way. It's fine if we want to retrieve a value by index, maybe once or twice, but if we want to take a look at all the elements, then this is not the best way to do that. To do that, we can use the iterator. If we want to loop over the elements, if we want to check all the elements, maybe we want to do something with each element, we can use the iterator. To get the iterator, we call the iterator method on the list. And this iterator will hold string values because ArrayList is storing string values. Oh, sorry. This should be iterator, not iterable. So once we got the iterator, we need to loop over the iterator. We need to check if there is an element, get me that element. To do that, we say it dot has next and it dot next. and we see all the values on the console. So this is yet another way to get the elements from the array list using iterator. And we know that we can use enhanced for each loop. If you want to understand the iterator and for each, then there is a video on iterable that you can refer. So to use the for each, we simply say, or just use the suggestion from the IDE. So we can say for each element in this list L1, I want to call the system.out.println, which means I simply want to print each element. So we see all the items on the console once again. So we added bunch of elements, then we retrieved elements by index. Then we tried to get all the elements using iterator, and the same thing with enhanced for each loop. What else can we do with the array list? So let's see. Then there is this add method, which means add the element to the given index. addAll can be used. So for example, if we have another collection and we want to add all those elements to this list. So let's try this. Let's say we have another array list of the same type. Let's name it L2. And this L2 has couple of elements. Item 5 and item 6. Now if we want to add all the elements from L2 to L1, one way would be to do it one by one, but then there is addAll method. So what we can say, L1.addAll and pass this collection L2. So we are saying that add this collection to this list, and which will basically append all the elements from L2 to L1. Okay, so now if we simply print L1, so we see all the elements, item 1 to item 6. So we can see that item 5 and item 6 were added to the end of the list. By the way, list overrides the toString method. That's why if we pass L1 directly to the println, it will print a nice view of the list on the console. Okay, so that is how we use addAll method. What else can we use here? Clear can be used to clear the contents of this array list. So if we want to remove all the elements, we can use the clear method. So let's use that. After calling clear. So here we should see all the elements in this list. Then we are calling clear. That should clear the list. And if we print list after calling the clear method, we should see an empty list. As you can see, we see an empty list after calling clear. So clear basically removes all the elements from the array list. Let's comment it for now. Okay. Let's move on to the next method, which is contains, this one. So let's say we have a list, we have a collection, and we also have a value, and we simply want to check if this value exists in this list. Does this list contain the given value? In that case, we can use L1.contains, which returns a boolean. So let's say we have a value, maybe simply item, and we want to check if this list contains this item. So we can say L1 dot contains and to check. And if we run the code, you see the false output because this list does not contain any element that matches the item. We don't have any element with name item. We can see that there are item 1, item 2, item 3, but not item. That's why we see the false output. But if we simply change it to, let's say, item 4, which is there in the list, in that case, we should see the true output. That yes, this list contains item 4. So we see true. Contains, we checked addAll, clear, clone, ensure capacity. ForEach, let's use the ForEach method. So let's say we want to do something for each element. For each element in the list, we want to perform some action. In that case, we can use forEach method. The forEach method accepts a consumer. So let's try to implement the consumer. As you can see, consumer accepts a value, the value from the list. For each value, it will be passed down to this consumer via accept method, and it is available for us to use in the accept method. So we can do something in the accept method. So let's say what we try to do is for each value, we want to say something like this, s dot to uppercase, or simply let's print the values in to uppercase. So you can see that all the values were converted into uppercase. Replace with lambda. So what we are doing here is we are calling the forEach method, then we are passing a consumer to this forEach method, and we are saying that for each element that you get from the list, call this code for each element, and this code is simply converting the value to its uppercase and printing it on the console. So that is a neat way to perform an action on each element. It will handle the iteration and it will apply the given operation. Okay. Let's move on to the next method. Get, we have already seen. Index of. So similar to contains method, contains checks if the list contains the given value. But if we want to know the index of that value, we can use the index of method. So let's say in the array list, we want to check the index of value item 5. In that case, we can use index of method. Index. I missed the semicolon. So we can see that index of item 5 that we passed is 4. We can check that item 1 is at the 0th location. So 0, 1, 2, 0, 1, 2, 3, and 4. The index of item 5 is 4, and that's what we see on the console. So to get the index of a given value, we can use the index of method. Okay. Is empty basically checks if the given list is empty or not. It returns a boolean. So if we check the status of list at this point of time, then we should see the value false because list is not empty. It contains elements. Is list empty? So we see false because list contains at least 6 elements. But if we clear the list and then call the empty, then we should see, yes, this list is empty. Here, because we cleared the elements, so right now list does not have any elements. Let me remove it. And let's make sure that everything is running fine. So we see the false again. So we saw is empty, and similarly we can use the last index of. We saw how to use and why to use index of to get the index of a given value. But let's say we have duplicate elements in the list, because a list allows duplicate elements. And what it will do if it contains duplicate elements, it will, if we are using the index of method, it will return the first index of the first occurrence. So let's talk about it. Let's see an example of this. So we know that the list contains these 6 elements: item 1, item 2, item 3, and to item 6. Let's add a duplicate item, item 6, and let's print the list before we use the last index of method. So we see these many elements in the list, and notice the duplicate element, item 6. It allows duplicates. So we see 2 item 6 values in the list. Okay. Now if we use the index of method, let's check the index of item 6. So it says 5. It says 5 because by default index of method checks the index of first occurrence. And let me print the list also, so that it's a bit easier to understand. So given this list, when we are calling the index of to check the index of item 6, the method returned 5, which is 0, 1, 2, 3, 4, 5. The index of this item 6, not this one. So it saw that there is a value item 6 in the list, and it returned the index of that item only, basically the first occurrence. But if there are duplicate elements in the list, and maybe if we want to check the last index of a given item, in that case we can use the last index of. So if we check the last index of the same value, then we will use last index of method. What it will do, it will basically start matching the item from the end, and it will get us the last index of that value. So we see 6 in this case. First is basically the first occurrence index of, and the last index returns the last index of that value, the index of the last occurrence. All right. Because we need to focus on the remove methods, so what I did, I commented everything from the previous video, and I added new elements in the list from scratch and printing the list on the console. So if I run the code now, we will see only the new list, basically item 1 to item 5. Now we can start discussing the removed methods. So let's say we have this list, and this list has 5 elements, item 1 to item 5, and let's say we need to remove item 3. How can we do that? To do that, we can just check what kind of remove methods ArrayList supports. Okay, so let's do that. Let's see what kind of remove methods are there. So we have remove that accepts an object, then we have remove that accepts an integer value, basically the index. So So this is basically to delete a value by index. Then we have remove all. So if we want to remove multiple values in one go, then we can pass a collection and it will try to remove the values from that collection. And then the fourth method is remove if. What we can do, in this method we can pass a predicate, a condition, and depending on the condition match, that value will be removed from the list. So let's see all these methods one by one. We can remove the value using the remove, and we can pass the value to this remove method. So what we can do, because we need to delete the item 3, we can simply pass a value to this method item 3. And because it will be a match, we have a value in the array list with the same value item 3. So it's a match and this value will be removed from the list. And if we print the list, after deleting item 3, then we should see 4 items, remaining items in the list. So we see item 1, item 2, item 3 got deleted, and then item 4 and item 5. So if we pass the value directly to the remove method, we can delete a value directly from the array list. The second way is to pass the index. So for example, all we need to do is, given we have this array list, we want to maybe delete the second value or by the first index. The second value will be at index 1. So what we can do, l1.remove, this time we can pass the index. So if I pass the value 1, then this is the index. And we have this array list. So the value at index 1 would be 0, 1, item 2. So in this case, item 2 will be removed and the resultant list will have item 1, item 4 and item 5. So let's check that. And we see that in this list, we don't see the item 2, which was at index 1, because we basically deleted the value at index 1. So we can pass the value directly or we can pass the index to remove the value from the array list. Next method in the list is remove all. Okay, so now consider this case. We have this list and this list has 3 elements. Now maybe the requirement is, maybe we have multiple values to be deleted at once and we want to delete values in a batch. So in one go we want to delete item 4 and item 5. We don't want to call remove methods one by one for multiple values. We simply want to call the remove method once and we want to pass multiple values to be deleted. So in this example, consider that we have to delete item 4 and item 5 in one go. So what we can do, we can create a new collection, and in this case we will simply create a new array list. So let's say array list type string, let's name it to be deleted new array list, and we'll add item 4 and item 5. And then we will say l1 dot remove all to be deleted, and let's print the list as well. So we see that we only have one element in the list, item 4 and item 5 got deleted. So how it works is, if we pass a collection to the addAll or to the remove all method, what it will do, it will simply check the existence of items from this collection. So first it picked item 4 and it will check if L1 has or L1 contains item 4. In this case, yes, so item 4 will be deleted from L1. Then it will pick second item from the collection, past collection item 5, and again it will perform the contains check. Because L1 contains item 5, so item 5 will also be deleted. And once all the elements that are in the list are deleted, then we get the final list. So that's why we see only one item in the list. Okay, so we saw how to use remove by value, then remove by index, and then remove all by passing multiple values in a collection. The last method in the remove category is remove if, that basically accepts a predicate, a condition. For that, let's say we have an array list. This time let's create a different array list of integer values, nums. So earlier we created an array list to store the string values, but we can create an array list to store the integer values. All we need to do is we need to pass the generic type of the data type. In this case, this is integer, so we can add only integer values in this list. So let's add bunch of values, 1, 2, 3, and 4. Let's add only 4 values. Now, let's say we want to delete all the even numbers from this list. So one way would be to iterate the list and apply the condition that if the current number or the current item of the list is an even number, then remove the item from the list. Another way would be, or the better way would be, to use the remove if method. It accepts a predicate, a condition. So let's try to implement the predicate. So how it works is when we call the remove if, it will iterate internally. It will internally iterate the array list and it will pass the values one by one to this test method. And these values will be tested against the condition, and this condition basically is given in the form of predicate. So once we have the value in the test method, we can simply apply a condition to this value. So what we are saying that if this integer is an even number, and if this condition is true, then that item will be removed from this list. And let's also print the list so that we can verify. So we see that the list had 4 elements, 1, 2, 3, 4, but after calling the remove if it basically deleted all the even numbers, and in the result, in the final list, we have all the odd numbers. We can now change it to the lambda. So we can pass a lambda because predicate is a functional interface. So we can pass a lambda, and we are saying that remove an element from this list if it basically passes this condition. And this condition simply says that the number that you get from the list, if this is an even number, then remove the item. And that's what it did. So that's how these are different variations of the remove method. Just to recap, just to revisit the same thing, we can remove the value by passing the value directly to the remove method. We can remove a value by passing an index. Then we can remove multiple values in a batch by passing a collection. And then in the last, we can remove multiple values by passing a condition, a predicate to the list. All right. In the last video, we saw that we can delete multiple values in a batch using remove all method if we pass a collection to this method. So what it does, basically, the values to be removed are passed in this collection. So the values that we pass in this collection, if these values are there in the list, then these values will be removed from the list. But what if we have to do the opposite? That means we want to keep the values, these values basically that we are passing in the collection. And so we are saying that the values that we want to keep will be passed in the collection, and everything else in the list must be deleted. To do that, we will use another method from the list, which is retainAll. So let's create a new list for this example. Let me copy this one. And I will simply change it to 5, 6, 7, 8. And let's name it nums1. Okay, so we have a new list, and this new list contains 4 values, 5, 6, 7, 8. This time we want to say that, let's create a new list before we see how retain all works. Integer, keep these, new array list, keep these dot add 6 and 7. So what we are saying that we want to keep these values and everything else from the list from the nums1 must be deleted. Earlier when we were using remove, or we were saying that these values must be deleted from the list. So we were passing the values that we want to delete. But this time we are doing just the opposite. We are passing the values that we want to keep. So we can say that nums1 dot retain all. This accepts a collection. In this case, we are passing the array list. So it will retain all the values that are there in the past collection. Everything else that is there in the list will be removed. In this case, values 6 and 7 will be retained, but everything else, for example, 5 and 8 will be deleted from the nums1. So if we run this code now, we see that we have only 6 and 7. Everything else from the nums1 got deleted. So that's how we use retain all. In this video, we will see a couple of more methods on the array list. One of them is to check the size of the array list. How do we check the size of the array list? Given we have this array list of integer type and this list has 4 elements, if we want to check the size of the array list, then we can use the size method. To check the size, we use the size method, nums.size. It will print the number of elements or the size of this array list, in this case 4. So we see 4. Second method in the list is basically to set the value. We added the value, we can get the value from the array list, we can remove the values, and we saw different ways to remove the values. Then there is one more method in the array list to set the values by index. So for example, we want to say that whatever list we have, set the value, or whatever value is there at index 1, we want to update it. So we can say something like nums.set. It accepts two values, number 1 index and number 2 the updated value. So we say that we want to update the index 1 and we want to update the value to, let's say, 21. And we know that this is 0 based index. So this is index 0, this is 1, this is 2, and this is 3. And in this case, we are saying that we want to update index 1. So what we are essentially saying is that we want to update this value 2 to 21. And if we print the list after calling the set method, we see that 2 has been updated to 21, basically the value at index 1. So that's how we use this set method. Let's see what else is there in the list that we can try. So sort, we will cover it separately. What else is there? Splitrator, stream. I have a different playlist basically that focuses on lambdas and stream, so I won't be covering stream in much detail here, but we will see a couple of examples on the stream. Then we have toArray. So we can convert an array list to an array. There are two methods, toArray, which basically returns the object array, and second variant of the toArray method returns an array of type T that we provide. So what I mean to say is, if we simply use the toArray method, then it will return an object array. That is fine, but we know that this array list contains integer values. So what we are saying that we want to convert it into an integer array. But if we try to do that, it will be a compile time error. It says that I am returning the object array, but you are converting it into an integer array, which is not allowed. Because by default, the return type of the toArray method is basically the object array. So we'll have to typecast it explicitly. So if we cast the return type, then it's fine. But there is another way to do that. There is another toArray method which basically accepts a T type of array. So we can provide the type here. We can simply say that I can pass an empty integer array just to provide the type. Now I say that I need to pass the value. So what I'm saying that I want to create or I want to convert this array list to an integer array. And this time I don't have to provide the cast. It will identify the type of the resultant array by this type, and it sees that, okay, this is an integer array. So I have to convert this array list to an integer array. And that's why this call is now green. It won't result into a compile time error. So we saw how to use size method, how do we update a value by index, then two variations of the toArray method. We have covered almost all the important methods from ArrayList. There are two things that we have not discussed with ArrayList. Number one is the sort method. So if we see, it has a sort method which accepts a comparator. So we will not discuss sorting here because sorting is a separate topic that is common for all the collections. We will cover the sorting when we cover comparable and comparator. So that is something that we will see later. Second thing is streams. All the collections, they support stream and parallel stream method in order to get a stream from that collection. So if we call the stream method on the array list, we will have a stream based on this array list. Similarly, we can get a parallel stream on the array list. Now we have another playlist that focuses on the lambdas and stream. So we will not be discussing the same thing here, but the idea remains the same. I would recommend to visit that playlist in order to understand all about streams. All right.